Let's look at the first warm-up question. It says find the Maclaurin polynomial for degree 6 for cosine x. Cosine x is equal to, this is an even function, so it starts with x to the 0 over 0 factorial. That's really 1. So I have 1, and then it alternates in sign. So 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x6 over 6 factorial. And it says stop at degree n equals 6, so I'm going to stop right there. This should actually be a squiggly sign, not an actual equals. And then it says use my answer here to approximate this. So I'm going to need to repeat this expression here. So first, I'm going to take cosine t, and I'm going to say 1 minus it. So if you have a plus or minus, you just tack on. So 1 minus cosine t will be equal to 1 minus, and we put the cosine t here. So that would be 1 minus t squared over 2 factorial plus t4 over 4 factorial minus t6 over 6 factorial. And I guess this really is an about equal to. And then you're going to divide everything by t squared. So I'm going to divide by t squared here, and let me put it in a different color. And I'm going to divide everything here by t squared. So this would be 1 over t squared. This would be 1 over t squared. This would be 1 over t squared, 1 over t squared, 1 over t squared. And what do I get here? I get 1 minus cosine t over t squared is equal to, this negative is going to distribute. So I have 1 t squared minus 1 t squared. That's going to give me 0. And then negative, like all these signs will become negative. So what I'll get is t squared over, oops, these t squares are going to cancel out. So I get 1 over 2 factorial minus, these t squares are going to cancel out. So I'll have t squared over 4 factorial plus, because that's negative, negative, and this will be t4 over 6 factorial. Okay, so that's what I get for 1 minus cosine t over t squared. And then what I want to do is I want to integrate both sides. Okay, so I'm going to integrate 0 to 1 on this side. That means I integrate 0 to 1 on this side. Since I do have limits here, then I'll have a win bar here when I take the antiderivative. So what I get is 0 to 1, integral of this, and of course there is a dt here. That's equal to, the integral of 1 over 2 factorial is basically 1 half t. The integral of t squared over 4 factorial will be minus t cubed over 3 over 3 times 4 factorial, and the integral of this term here will be plus t5 over 5 times 6 factorial. I do have a win bar, and this will go from 0 to 1. And this says everywhere I have a t, I'll plug in a 1. And so this is equal to 1 half times 1 minus 1 over 3 times 4 factorial plus 1 over 5 times 6 factorial. Everywhere there's a t, I'll plug in a 0. That gives me 0 minus 0 plus 0. And this should be about equals 2. And so then I slap a minus sign in between. That's the first fundamental theorem of calculus. This goes away here. And so this is what I have for the approximation of this integral. Okay? And what's the question? It says, use your answer in 1a to approximate the value of this. So I've approximated this value. And show that my approximation is less than 1 over 500. Okay, so if I call this the approximation, then what that means is this right here is the actual value. And whatever I have right here, this is what's called the remainder, or the error. Okay, and if I put a line right here, the next term, whatever this term is called the remainder bound. So whatever this next term is here, this right here, will be called the remainder bound. or the error bound. The bound of the remainder or the error bound. And what is this term? Well, if I just look at the pattern here, I think I can get it. This term is going to be 1 over 6 times 7 factorial. Okay, and what I'll do here is I'll say, is this an, if I use the alternating series remainder bound theorem, it says that if I say this is approximation, okay, I'm wrong by no more than the next term. So this will say this will only be true if this is an alternating series that converges. So I have to say the terms 1 alternate, and they do, not minus, plus, oops, minus, right? Okay, the terms have a limit of 0. Okay, and they do. And then third, the terms decrease in magnitude, and they do. Okay, each number is less than the number before it. And if this is true, then that means my error, okay, is less than or equal to this number right here, the absolute value of this number right here, so 6 times 7 factorial, which is less than or equal to, and I have to show that that is less than or equal to 1 over 500. And is this true? Well, I can I can look at my calculator and say, what's 6 times 7 factorial? So I'm going to go to my calculator here. Pull my calculator in here. Oops. And 6 times 7 factorial, what is 7 factorial? Times 6 times 5 times 4 times 3 times 2 times 1. And so that's 30,240. So this number here is 30,240. And is this number less than this? Check, it is. All right, let me make sure I answered the question. Use my answer in 1A to approximate this value and show that the error is less than 1 over 500 and justify your error. And I did justify my error. Okay, that's how you do that problem. Let's go ahead and look at homework questions from last night. Last night you did this problem, and so today what we're going to do is we're going to show you this error says that if I call this my approximation, meaning if I say that the integral of 0 to 1 of 1 minus cosine t over t squared dt is equal to 1/2, well, I guess it's really about equal to, but if I say that is about equal to 1/2 minus 1 over 3 times 4 factorial plus 1 over 5 times 6 factorial, right? Factorial. Then if I say this is my value for what this integral is, then I'm wrong by no more than 1 over 30,240. All right, we did this question last night, and I want to talk about how we can do a shortcut for this. So last night, if you did this question, you had to figure out the Maclaurin series for this. So this is really 1 over 1 minus 2x. You have to set up a table. This is 1 minus 2x raised to negative 1. The derivative of that is negative 1 minus 2x. Take the power down by 1, and don't forget to multiply by the derivative of the inside. And then this one here is really equal to 2 times 1 minus 2x negative 2, which is really 2 over 1 minus 2x quantity squared. If I take the derivative of this, I'll get negative 4, 1 minus 2x raised to negative 3. Don't forget to take the derivative of the inside. And here I'll get 8 times 1 minus 2x. The quantity 1 minus 2x raised to negative 3, which is really 8 over 1 minus 2x raised to the third power. If I do the third derivative would be negative 24 times the quantity 1 minus 2x raised to negative 4. Don't forget to multiply by the derivative of the inside. That was a positive. So what I get here is 48 times 1 minus 2x raised to the negative 4, which is really 48 over 1 minus 2x to the 4th power. And here they said 4 non-zero terms. I'm hoping these are all non-zero. If they aren't, I'll add another term later. Then what you do is you plug in your 0 and, you plug in your center. You plug in your center. This is a Maclaurin series, so my center is 0. So this will be 1 over 1 minus 2 times 0, which is 1. If I plug in my center here, this will be 2 over 1, which will be 2. If I plug in my center here, this will be 8. And if I plug in, 8 over 1, which is 8. And if I plug in my center here, this will be, 48 over 1, which is 48. Okay, so I've got all my derivatives, and I put this into the Taylor series. So that means f of x, which is 1 over 1 minus 2x, is approximately equal to, and so you put it into the Taylor series formula, and this is my Taylor series formula here. Okay, since the center is 0, I don't have to put 1 x minus 0. I mean, I can. This would be f, the second derivative at 0, x squared over 2 factorial plus the third derivative at 0, x to the 3rd power over 3 factorial. I'll plug in all these numbers that I found for the derivatives. So this will be 1, this will be 2, this will be 8, and this will be 48. So what I get here is 1 over 1 minus 2x is approximately equal to 1 plus 2x plus 8x squared over 2 factorial, which is 4, right? So that's actually 4x squared, and then this is actually 6. So 48 divided by 6 is 8, so this will be 8 cubed plus dot dot dot, okay? They also asked me for the general term. So if I look at the general term here, this is kind of interesting. This is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3rd, right? So I think what's going to happen is I'm going to get plus 2 to the n of x to the n, and that's going to be my general term. There's no alternating factor here. All right. And I think I'm done with this problem. That's what you had to do last night. So what we're going to do is we're going to try to form this Taylor series, but without doing this table. So remember, we've got the shift trick, if the function and the center shift together. But that's for sine x, cosine x, e to the x. But what do we do when we don't have that? How do we shift things? So if you look at 1 over 1 minus 2x, I want you guys to notice that 1 over 1 minus 2x actually looks a lot like a1 over 1 minus r. When we talk about a series, okay, we're really saying that the series is a sum, right? That's what series means. What that looks like is it looks like the sum of a geometric series. Okay, so if that is a sum of a geometric series, then this would be equal to, some geometric series, right? And so I wonder what that geometric series is. There's a formula here, a to the 1, I think it's a to the 1 raised to the rn, okay? Depends what your n starts with right here. And that you can also say that that is the sum of a geometric series. So if I look at this, I can say, you know what? This looks a lot like a1 could be 1, and my r could be 2x, right? If that's true, then what would the sum of this a1, that's 1, r would be 2x raised to the n. What would that sum be? Well, let me think about that. Well, if I start with a1, that's my first term, so that'll be 1. And then if it's a geometric series, I multiply by 2x, so that would be plus 2x. And then I multiply that by 2x, so that would be 4x squared. And I multiply that by 2x, okay, that would be 8x to the third. Is that the same thing that I got before for the Taylor series? Let me look at this. This is the Taylor series I got for 1 over 1 minus 2x. Let me compare that over here. Is that the same thing? Why, yes, I think it is. So this is kind of a shortcut to figure out the Taylor series for something that looks like a geometric sum. So it's got to have this format in here. If I want to be a little bit more specific, let me think about this. If I plug in 0, I'll get 1 here. So this is where n is equal to 0. If I plug in 1 for n, I will get 2x. So this goes from n equals 0 to n equals infinity. Okay, but here's the thing. Remember, this thing right here is only true. Okay, it's only true. The geometric series test says this is only true if 2x is what? If the absolute value of 2x, which is r, right? So if the absolute value of r, okay, is less than 1, that's the only time this thing converges. So if they ask you for the interval of convergence here, okay, this may not be equal all the time, okay? That's why I put a squiggly here. It may not be equal all the time. It's only equal where these two sides are only equal when 2x is actually less than 1. Okay, so what you have to do if they ask you for the interval of convergence is you have to say, well, the absolute value of 2x must be less than 1. Okay, how do I get out this absolute value? So that'll be negative 1 is less than 2x is less than 1. Divide every single portion here by 2 so that I can get the x by itself. So what I'll get is negative 1/2 is less than x is less than 1/2. And this is the interval of convergence where this is true, where 1 over 1 minus 2x is equal to this series here, 1 plus 2x plus 4x plus 8x cubed, and on. Okay, now notice, before today, when we talked about interval of convergence, and we talked about the radius, we said use the ratio test, and then you had to test your endpoints. The reason you had to test your endpoints was that the ratio test was inadequate at the endpoints. At the endpoints, your ratio test would actually make your limit equal to 1. And do you remember on the ratio test, if the limit as n goes to infinity of the a to n plus 1 over n an was equal to 1, this was inconclusive. So that's why you had to test your endpoints. But guys, this over here is a geometric series test. And if you go look at the back page of your formula sheet, the geometric series test, okay, does not have anything where if it's equal to 1, you're inconclusive. The geometric series test says in order to find the interval of convergence, all you do is you set your absolute value less than 1. If it's equal to 1, then it diverges. Okay, so you don't have to worry about being equal to 1. The interval of convergence only happens when the absolute value is less than 1. So guys, for the geometric power series, okay, when you figure out your interval of convergence, you do not have to test the endpoints. Okay, if you do test the endpoints, what you'll find out at the endpoints is that you won't converge because you'll get r is equal to 1. And we already know at r equals 1, you diverge for the geometric series test. So what I did was I took this summation right here and I tested it using the, I think I used the ratio test, and I used the ratio test instead of using the geometric test, and you guys can look at my notes, and then I did test the endpoints, and I got the endpoints diverges. And of course, I would expect it to diverge because already using the geometric series test, the interval of convergence test for that, I already knew that the endpoints would diverge, right? There's no equal sign here and there's no equal sign here. All right, so just a summary. If you are using the geometric power series test to figure out your interval of convergence, you do not need to test the endpoints. If you're using the ratio test to figure out your interval of convergence, you do need to test the endpoints. Okay? All right, so let's look a little bit more into our notes. Suppose I said start with a1 equals 2 and r is equal to 3. What would your series be? Okay, so that would be my f of x, I guess, or my function's about equal to 2 plus, and then you'd multiply by 3, right? 6 plus, you multiply by 3, 18 plus, you'd multiply by 3, 54 plus, dot, 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 plus. And how would you write this nth term? It would be a1r to the n. Okay, so let me put this. This is the summation here is a1r to the n. If you wrote it, a1 would be 2, your r here would be 3, and you take it to the nth power. Okay, and that's how you write the nth, the general term, okay, for a geometric series. All right. Does this series converge? Can I get a sum here? Can I get a sum value here? Okay, no. Okay, why not? Because my r is greater than 1. My r is equal to 3, which is greater than 1. So you cannot calculate a sum here. All right. If I were to write this summation here, this would be, if I were to write the expression of the summation here, this would be 2 times 3 raised to the n. Okay, from n equals, and this would be have to be 0 for your first term here to be 2. So n equals 0 to infinity. All right, what if I had to write this geometric series here? Okay, this geometric series would be a1 times r to the n, which would be 2 times negative 3 raised to the n. And what does that equal to? Okay, I'm going to start at n equals 0 and end at infinity. So the reason I'm starting with n equals 0 because my first term has to be 2. And to plug into this formula to get 2 here, n is going to have to be equal to 0. And then my second term is going to be multiplied by negative 3. So that'll be negative 6. And then multiply by negative 3, that'll be positive 18. Then multiply by negative 3, I'll get negative 54 plus dot 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 plus. How do I write my general term? It's basically this part right here without the sigma. Okay, do not put the sigma in the general term because you don't add all this and then add the sum again. Okay, you just put this a sub n here into the general term, and that would be plus dot 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 dot. And the question is, can I calculate a sum here? Okay, what's my absolute value of r equal to? 3, and that's greater than 1. And so geometric series test says I cannot calculate a sum when r is greater than 1. All right, what if I said a1 is equal to 1 and r is equal to x? The expression for that would be n equals 0 to infinity of a1, which is 1, times x raised to the n. Okay, and I can just plug numbers in here. But what will happen is, I know my first term is 1. I can check that out. Plug in n equals 0. Do I really get 1 for the first term? My second term, my r is x, right? So then I'm going to multiply by x. And then my third term, I'll multiply by x again. And then my fourth term, I'll multiply by x again. Okay, so what is this general term going to look like? That's x raised to the n plus dot dot dot. And does this one have a sum? If I sum all of these numbers up, I'm going to get a1 over 1 minus r. Okay, but what has to be true is this r, right, is x. So this would be 1 over 1. Okay, the a1 is 1 over 1 minus x. Okay, so this would be my sum right here. Okay, but the thing is, this is only true if what? You only get a sum if what? The absolute value of your r, okay, so the absolute value of x is less than 1. Okay, so this, for this power series here, this expression, this summation is only true if x is between what? negative 1 less than x less than 1. Okay, so this is your interval of convergence, okay, for this problem up here, for this sum series up here. And it would only be true, okay, you can only have a sum if this x is between negative 1 and 1. Okay, I don't have to test the endpoints for this interval of convergence because the geometric series test says that as long as this expression here is true, okay, the series will converge. Okay, this is not, I did not do a ratio test, so I do not need to test the interval of convergence. All right, so let's look at a type of question you could be asked. You could be asked, find the power series for this centered at 0. Okay, and of course, you could do f of x, okay, is equal to 1 minus x squared raised to the negative 1. And then you take the derivative of that. Okay, and then plug in your center. I mean, you can do all of this, all right? But today we're doing a shortcut. And that shortcut is, if you notice that the sum that they give you, the function that they give you, looks like, okay, it looks like a1 over 1 minus r, or if you can manipulate it to look like this, okay, then you can actually do a shortcut to figure out what your series is. So the way you do that is when you look at this problem, okay, this is 1 over 1 minus x squared. Okay, when you look at this problem, you can see that your a1 is equal to 1 and your r is equal to, okay, let's match it. Your r is actually equal to x squared. So this is equal to, right, this summation is equal to 1 plus, then you multiply by x squared, then you multiply this by x squared. Now make sure we're multiplying right. X squared times x squared is going to give me x4. Then you multiply by x squared again. So x4 times x squared will give me x6, and so on, plus. And what does this series look like? This series looks like x. I think if this n is equal to 0, this n is equal to 1, this n is equal to 2, this n is equal to 3, that will be x raised to the 2n. There's no alternating term here. Then plus dot dot dot. Okay. If I wrote this into a summation form, which you actually don't have to, but if you did, this would be a1 r to the n for geometric series from n equals 0 to infinity. So that would give me the summation of n equals 0 to infinity. A1 is 1 r raised to the n, so my r is x2 raised to the n. That would give me the summation of n equals 0 to infinity of x to the 2n, okay, which is exactly what I expected right here. Again, do not put a summation here. This is incorrect, okay? Do not do that because this summation is not equal to everything added plus the sum again, okay? If you do put a summation, which AP will never require you to put an answer with the summation, but if you do, this whole thing here would be equal to the summation, okay? The general term never had a summation in it. All right, so I've written this these terms for this series. I did a shortcut. You can actually do the table and see if you get the same answer for fun if you wanted to. But this isn't always equal to 1 over 1 minus x squared, right? It's only equal to 1 over 1 minus x squared, because this is a geometric series, when your r, so your r, must be less than 1. Okay, that is the requirements for a geometric series test. So this series will converge, okay, when the absolute value of x squared is less than 1. All right, which is really your r. So what is the absolute value of x squared? Well, x squared is always positive, so that really is just saying x squared is less than 1. Say, first you have to say x squared is equal to 1, and then you put it into a number line, and this is true at plus or negative 1. So you put into a number line plus or negative 1, and you test these intervals to see which is true. That's how you do an inequality, okay? So you have to find the numbers to put onto your number line, test 0. If I put in 0 here, would 0 be less than 1? Yes, that's true, so you color that in. What if I put in, 5 here? You know, what if I put in 5? Would 5 squared be less than 1? No. So you would not color in this part. What if I put in negative 5? Would negative 5 quantity squared be less than 1? No, that's not true. So this is all I have. This is my answer. If I plug in negative 1, would negative 1 be less than 1? Negative 1 squared, is that less than 1? No. 1 is not less than 1. Okay, so the answer here would be, your interval of convergence would be x is between negative 1 and 1. This is, so you're saying that this fraction is equal to this series when, you know, x is between negative 1 and 1. That is called your interval of convergence. All right, so to see what we're saying here, we could put this into our calculator. Put this function into your calculator. Put in y equals 1 over 1 minus x squared. Okay, so 1 minus x squared. Okay, graph that and compare that with this series here, plus x squared plus x to the 4th plus x to the 6th. And that's 1, 2, 3, 4. Let me put in another term. So x to the 8th. And let me put this here as a boldface. So I'm going to toggle this into a boldface. And so the boldface graph will be my estimate. If I graph this, okay, so do you see, there's my boldface. If you look at beyond negative 1 and 1, so if I graph, so this is my estimate right here. Okay, if I trace at 1/2, so go to 1/2. If I trace 1/2, and so 1/2 is right about there. There's this is about 0.6. This is about 0.4. Do you see? It's a pretty good estimate. Okay, but if I go to x equals 2, which is outside of this interval of convergence, so if I go to x equals 2, I'm going to move to x equals 2. X equals 2 is somewhere right here. Do you see that this boldface graph, which is my estimate, is not going to be a good estimate for x equals 2. Okay, x equals 2 is a negative number, and for this function, for this sum, I guess, but it's not going to jive with this Taylor series estimate that I got, and so that's why the interval of convergence is between negative 1 and 1. It won't work for 2. All right, let's find a power series for 12 over 4 plus x centered at x equals 0. Okay, now this one, we gotta pay attention to the center here. Okay, the center must be x minus 0. So it is, you know, you notice that this x, right, doesn't have a minus 3 or something like that. That would be a different center, right? So this, and I say this looks a lot like, does it? It looks a lot like a1 over 1 minus r, or I'm hoping that it will. Okay, so what I need to do here is make this a 1. Okay, make this a 1. And there's different ways to make this a 1. Okay, I could subtract, I could subtract 3. Okay, but that's not actually a good way to do it, and I'll tell you why. Because if I subtract 3, I also have to add 3. And so what will happen is I'll get 12 over 1 plus x plus 3. Okay, and so what will happen is this right here becomes my r that you keep multiplying by each time. And in a Taylor series, if you keep multiplying by x plus 3, and then you multiply by x plus 3 again, and you multiply by x plus 3 again. Do you see my center now will be negative 3? Okay, so that would change the center here that I have at x equals 0. So whatever I do here to make this into this summation format, I have to do it so that x remains an x, meaning it doesn't have like a plus 3, it doesn't have a horizontal shift to it. Okay, so the way to do this is not to subtract 3, but it is to divide by 4. So if I take this 12 and divide it by 4, and every term, if I divide it by 4, okay, I'll still keep the shift here at 0, meaning the center here at 0. Okay, so this will be 3 over 1 plus x over 4. Okay, and how can I make this look even more like this a1 over 1 minus r? This must be a negative sign, so this will be 3 over 1 minus negative x over 4. Okay, and now I've changed this, so this could be my a1. My 1 minus is great. This is exactly what I want. Then this means my r is equal to negative x over 4. So this means that 12 over 4 plus x is approximately equal to a1, so you put 3, and then every subsequent term you multiply by negative x over 4. So the next term will be 3 times negative x over 4. The next term will be this term, which is 3 times negative x over 4 times negative x over 4. The next term will be 3 times negative x over 4 cubed, and so on. And if I get the general term here, this would be 3 times negative x over 4 raised to the 4. Okay, I could also have found the general term by saying the summation of a1 r to the n, as n equals 0 to infinity. My a1 here was 3, oops, this is a summation. My r was negative x to the 4 raised to the n, as n goes from 0 to infinity. All right, and so here's a question. I've done the Taylor series here. This basically here is the Taylor series. Let me, I guess I could simplify it a little bit. That's going to be 3 minus 3x over 4 plus, this will be negative x squared, so it is a positive. So it would be 3/4 x squared. This will be negative, so this will be negative 3/4 x cubed. And you can see, oops, that's not x4. This would be approximately equal to 3 minus 3x over 4. This would be negative x squared, which would be positive on top. Okay, on bottom though, I have 4 squared, which is 16. On top here, I'll have negative x cubed, so that's negative 3x cubed. On bottom, I have 4 times 4 times 4, which is 64, and so on. Okay, so to get the interval of convergence, what I'll do is I'll say this series converges when the absolute value of negative x over 4 is less than 1. Okay, this 4 is a positive 4, so I'm going to multiply everything by 4. So I'll get the absolute value of negative x is less than 4. Okay, and so what I get is x is between negative 4 and 4. And that's how you do this problem. And we should test it to make sure this is true. So plug in a number, like put in, let's say negative 4, 4. Put in 0. If I put 0 here, is that less than 1? Yeah, check. If I put in 5, is that less than 1? That would be negative 5/4, absolute value less than 1. No, it's not. Okay, so your answer is here between negative 4 and 4. And in the geometric series, you do not need to test the endpoints. Let's do this problem right here. For what is the first 4 non-zero terms? What's the general terms? And when does my series converge? Notice here though, your center must be 3. Okay, so right now, well, let's find my r. I need to find my r, but my r needs to have x minus 3 in it, right? Because this is a Taylor series. And so I want to multiply at least, you know, by x minus 3 again and again and again, okay? So the first thought I do is I say this looks like a geometric series. Okay, I could do a whole table for this and take derivatives, but it looks like a geometric series. Okay, if it does, then the sum is equal to a1 over 1 minus r. And how do I get this 4 to be a 1? Okay, now if I went back to what I did in the previous problem, maybe I divide everything by 4. Okay, and so the problem with that though is, let me get this. The problem with that though is when I get this a1 over 1 minus r, while it looks like a1 over 1 minus r, my center is not at 3. Okay, my center here is actually at 1. That's the shift here at the x, so to speak. Okay, that's your r. And you want your r when you multiply to have this x minus 3 in it. Okay, so how else can I change this so that I have a 1 here, but also have an x minus 3 here? And so this problem is specially concocted to work. But if you subtract 3 here, right, wouldn't you get a 1? And this would be minus x. If you subtract 3, you better add 3 also. Okay, so check out what I have. Does this give you 4 minus x on the bottom? Check it out. Make sure it's still 4 minus x. Okay, yes it is, because that's 1 minus x plus 3, which is 4 minus x. And then you say, okay, 4 minus 3 is actually 1. If I pull out a negative 1 from this, x plus negative x plus 3, I'll get x minus 3. And then check that. Make sure that that still is 4 minus x. This would be 1 minus x plus 3, which is 4 minus x. Good. Make sure you did not change the value of your denominator. So I have rewritten this so that I actually do have a center at 3, and it looks a lot like a1 over 1 minus r. I have a 1 minus here and a center at 3. That's exactly what I want. So what that does is that gives me a1 here. That gives me my r right here. Okay, so let me write my series. Okay, so 5 over 4 minus x, or you could say your function, okay, is approximately equal to, your a1 is 5. Okay, every time you add another term, that term gets multiplied, the previous term gets multiplied by x minus 3. So this is going to be plus 5 times x minus 3 plus 5 times x minus 3 times x minus 3 plus 5 times x minus 3 times x minus 3 plus dot 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 plus 5. The general term would be x minus 3 raised to the n plus dot dot dot. Okay? So what is this saying? This is saying, hey, this is a geometric series. But it's a geometric series only when the absolute value of r is less than 1. And what is my r here? My r here is x minus 3. So this is only true when the absolute value of x minus 3 is less than 1. So the way you get rid of the absolute value is you put this between negative 1 and 1. Then you add 3 to every part here. As long as you do the same to each part, you're okay. So you get 2 is less than x is less than 4. Okay? And this is your interval of convergence, meaning this sum is true, okay, when x is between 2 and 4. Okay, they could ask you for, this is the interval of convergence, they could ask you for what's the radius of convergence. Well, between 2 and 4, do I know my center on this problem? What's my center? Wasn't my center equal to 3? Okay, so my center is 3, and so the radius convergence would be equal to 1. Okay, and the series will converge from 2 to 4, not at 2 and not at 4. Okay, because the geometric series says r cannot be equal to 1. It's only between. R has to be less than 1. All right, and we did not use the ratio test, so therefore we do not have to test the endpoints.